Hello guys, welcome back to my channel, Memo African Motives. Still working on engineering science N2. So in this platform, actually we are going to work on the question paper which was written in July 2021, that is on dynamics. We want to have a continuation which is actually working on question papers as usual. So if you're new guys, you can consider being part of the family by subscribing so that you won't miss any of the classes that we shall be having from Memo African Motives. So quickly looking into the questions that we have there, if we are to cross check, we have got 15 marks for that, for this question that we have here, and that's a lot of marks for question number one. So let us quickly do the questions. The first part is to define each of the following terms, which is displacement, that is and also acceleration, and we've got 2 marks for that. So just like that, guys. So that is the displacement. It is the straight distance from starting point to end point, and this displacement is actually measured in meters. Then on 1.12, which is acceleration, that is the rate of change of velocity, or the rate of velocity change, which is actually measured in what? In meters per square second. So take note that acceleration, that is the rate of change of velocity, which means it's change in velocity over change in time, like that. So that is what you're actually referring to as the acceleration, and measured in meters per square second. So it's very, very important also to note about the units. All right, on 1.2, we're given that a motorbike is traveling at a constant velocity. So this one is a constant velocity of 30 meters per second for 15 seconds, and accelerates for 10 seconds. So take note, it accelerates for 10 seconds, reaching a velocity of 50 meters per second. Draw the velocity time graph of the motorbike speed over the total time taken. All right, so how are we going to have this presentation? Okay, let us just have our axis to represent the velocity and the time. Take note, this is velocity time, so it's supposed to be having velocity and time. That is the idea there, something like that. All right, so what are we having? We are going to have, this is our time axis. All right, so remember that our time is actually measured in seconds, and this will be your velocity. Let me just write like this: velocity here, which is measured in meters per second. All right, sorry, I hope it's clear, but so something like that. So that is what you're going to have, guys. So what is happening is that this object is actually at a certain velocity, which is a constant velocity. So a constant velocity, that's a straight horizontal line. So we're going to draw a horizontal line at 30. That's the velocity, and it's for 15 seconds. So you can just draw a straight line to show that it's a constant velocity at a certain point. Let's just say it's at this point. So that's a constant velocity like this. It's on air. It's supposed to be a horizontal line. So this is your velocity here at 30. That is 30. Take note here. It's 30 for 15 seconds. So this is your 30 here. All right. Then the time is going to correspond with 15. So you just indicate here. It's going to correspond with 15. So this is for the 15 seconds. And accelerates. Now there is an acceleration. Whenever there is an acceleration, which means we are having not a horizontal line, but now it's supposed to be like this. Whenever there is acceleration, deceleration is supposed to go downwards like this. All right, so depending, is it a positive or is a negative? So positive is supposed to be the first one. So it's going to accelerate for 10 seconds, reaching a velocity of 50. So which means, as you can see, also the velocity has changed. So this is going to accelerate. So we are going to draw it like this because there's an acceleration here. So it's going to be like this. This is what we are going to have at the end. Sorry for that. Okay, something like this. Okay, then here you just indicate to show that it's going to reach a certain time. All right, it is going to reach a certain time. All right, like that. And also let's just try to increase this side here so that we can join. Just here you just use broken lines. Don't use continuous line because it's just a presentation to indicate the corresponding velocity. It's not like it's part of the graph. It's just to indicate that velocity is corresponding with the value of what? Of 50, because the velocity is now at 50. So which means this value here is now at 50 because it is accelerated from this point up to this point, which corresponds with 50. And also here the time, it's for 10 seconds. So which means from this point to this point we've got 10 seconds. So we're going to add to 15, 10 plus 15 plus 10, which is actually 25. So which means it's going to end at 25. So you just add so that the difference between the two here is 10. So you indicate 15. These are the most important points to indicate 0, 15, 25, the velocity of 30, and also the final velocity of what? Of 50. All right, so that is it, guys. You can actually obtain 5 marks for that. And also take note, all the sketches, the drawings that you shall have should be in pencil. That is what is important. Okay, calculate the acceleration of the motorbike. Okay, so we are not even told the interval where we are calculating the acceleration. Why is that? Okay, let's cross check on our diagram. If you are to cross check properly here, there is no acceleration from this point to this point for the first 15 seconds because it was a constant velocity. Remember, on a constant velocity, the acceleration is equal to, which means there is no acceleration. So acceleration took place on this part here when it started to accelerate, to increase in speed. That is where acceleration took place. So we are going to calculate acceleration for this part here from this point up to this point. All right, so how do we calculate this acceleration? Remember, guys, this formula is not new. I've been talking about this. This is 1.22. I said that acceleration is actually the change in velocity over the change in time. What does this mean? It means the final velocity minus the initial velocity over the final time minus the initial. So it's just v2 minus v1 over t2 minus t1, where it ended minus where it started. That is what it means: initial, final, and initial. So what is the final velocity here? As you can see, it accelerated from this point up to this point. So this is your final velocity here, which corresponds with what? With 50. So your final velocity is 50. Your initial velocity here, it corresponds with 30. So it's 50 minus 30. Minus, you move on to time. It started at this point up to this point, and this point corresponds to 25. So it's 25 minus 15. So we're going to subtract 25 minus 15. That is the change in time. So if we subtract, simplify properly there, you're going to obtain 2. And take note, this is acceleration, which is measured in meters per square second. Or someone can write this as 2 meters per square second in this way. It's still one and the same thing. So this is your acceleration, which is the change in velocity over the change in time for the given time that you're having there. All right, so that's 1.22, which was on acceleration. Then another question is calculate the displacement of the motorbike for the duration of the observation. All right, what is the displacement? Okay, we know that displacement actually is equivalent to the time, to the area that is under the graph. That is displacement there. So you want to calculate the displacement. So you can actually equate to the area under the graph. But how are we going to take this area under the graph? Area under the graph, or area under graph. All right. So if you had to cross check here, there are so many ways that we could have done. As for me, because we've got this shape and this shape here, so this can be a trapezium and a rectangle, but I can choose to combine like this here to make this one like this. As you can see, this is now a rectangle here. I'm now having one rectangle. Are we seeing that? So this is a complete rectangle, okay? And here I'm having a triangle on this part. So I'm talking about the part where the object moves from this part here, that is the area under the graph, not this one. This one, we are not talking about it. We're talking about this two. So here, I'm just combining. I'm not going to focus with this part here. I'm just going to combine this into one and this into a triangle. So I've got 1 and 2 shapes. Take note, guys, we took this. We could have calculated this one and this one and this one, but we can combine this to give us one rectangle, okay? So which means we are talking about area of a rectangle, which is length times breadth, plus area of a triangle, which is half base times perpendicular height, half BH. So length times breadth from this rectangle, we have got this side is 30 and this side is 25. So it's 30 times 25. 30 by 25 plus half BH, which is half base times the perpendicular height. So this is the triangle here. Take note, guys, from 15 to 25, we said we've got 10 units. So this part and this part here is 10. Okay, you subtract 25 minus 15, that is 10. Also on this part here, from this point to this point, that is from this point to this point, so you subtract here 50 minus 30, which is 20. So this one is 20 here. So this is your triangle, half base times perpendicular height. So it's half of 10 times 20, like this. All right, so that's area that we are going to have in this case. So if you multiply 30 and that's 25 and 30 there, this part that we have, we're going to obtain something like 750 plus 100 from your calculator. If you multiply this, it's going to give you 100. So if you add, you're going to obtain 850 meters. So this is displacement. Remember, guys, displacement is actually measured in meters. All right, then last part, which is giving 2 marks, there is to calculate the average velocity of the motorbike. What is going to be the average velocity of the motorbike? So remember, guys, velocity is all about the displacement or the distance which was taken over the total time. So already we calculated the displacement, so it's going to be easier for us to have the velocity now. So this is 1.24. So we are going to have our velocity as the change in displacement, or the displacement, which is the distance which was taken. So we're just going to use the displacement, and that's displacement over time taken. So this is the total time taken actually of the observation. So according to the displacement of the observation that we had, it was 850 meters. So this is what you're going to have here over the total time which was taken according to our observation from 0 to 25. We've got 25 seconds. That's your time there. So you're going to divide by 25. Okay, so doing this, we are going to obtain something like 34. This is going to be 34, and that's velocity, which is actually measured in meters per second. So take note, if you are working with velocity, velocity is given in meters per second, acceleration meters per square second. So you are supposed to be very, very careful with the units there. Okay, so that's it, guys, on this question of dynamics from Mason African Motives. Till we meet again.